So now that we've gone through and we've used the properties of logs to find numerical values, we can also go ahead and expand using the properties of logs for algebraic or variable expressions, okay? So we're going to go through a few different examples of that. So for problem number 5, we have log base 6 of x to the 5th. Now the inside is just plain old x to the 5th. There's no product, there's no quotient, but there is an exponent involved. And our third property says that if there's an exponent on the inside, it can be pulled out in front as a coefficient. So this is really the same thing as 5 log base 6 of x, all right? Which doesn't seem like much, but this would be an easier expression if we needed to go through and say evaluate it for a number or to type it into a calculator, okay? So this is the expanded version of log base 6 of x to the 5th, all right? Many problems will have multiple pieces on the inside. So when I'm looking at number 6, the inside is really a to the 3rd times b to the 4th, okay? That's what's inside of this logarithm. So the first thing I'm going to do is I'm going to take that multiplication and split it into a sum. So I can say that this is really log base 7 of a to the 3rd plus log base 7 of b to the 4th, all right? Now, the 3 and the 4 as exponents apply to the individual pieces, the a and the b respectively. So I can't pull them out right away. The reason I could pull out the 5 in the first problem right away is because it applied to the entire inside. But when there are multiple exponents, you really need to split those apart first before you can pull the exponents out in front. But that is my next step. I have an exponent here that can get pulled out in front, and I have an exponent here that can be pulled out in front, okay? So now I'm going to have 3 log base 7 of a plus 4 log base 7 of b. And this is fully expanded. Expanded basically just means that you've split apart any products or quotients and you've also pulled out any appropriate exponents. You're trying to get the inside expression down to a single variable whenever possible. Okay, let's take a look at a couple more. So for problem number 7, the first thing I notice is that there's a division in here, okay? See this division? I'm going to deal with that first. So I'm going to split this apart into log base 3 of the numerator, 9x to the 10th, minus log base 3 of the denominator, y squared, okay? So you always want to split apart multiplication and division first. Now, it doesn't really look like much, but there is, in fact, multiplication right here in between these two pieces. So the next thing I'm going to do is split that apart. This is really log base 3 of 9 plus log base 3 of x to the 10th. And then I still have the minus log base 3 of y squared, okay? And the purpose of that is the 9 has is related to the 3. I can simplify that down even further. I can say this is log base 3 of 3 squared. Same base means I'll be able to simplify, all right? The other reason why I want to split those apart is this exponent 10 right here only applied to the x. It did not apply to the 9. So I couldn't pull out that 10 until I split the 9 apart from the x to the 10th. So now the next thing I'm going to do is I'm actually going to take that 10, I'm going to pull it out in front now. I'm also going to take the 2 and pull that out in front, okay? So the exponents can come out in front at this point. So I'm going to have 10 log base 3 of x minus 2 log base 3 of y. And the only thing left to simplify here is this guy right here. Because it's base and base match, all of this will essentially cancel off, and we're just left with 2 plus 10 log base 3 of x minus 2 log base 3 of y, okay? So that's the fully expanded expression for problem number 7, okay? So that one was really long and involved, and that's probably about as bad as it's going to get for us, all right? I used a little bit more space than I predicted I would, so let's just section this off here. All right, so next up, I want to take a look at problem number 8, and when I look at number 8, I see log base 5 of x plus 1, and there's a plus here, but there was no rule saying what to do if there's a sum inside. If it was x times 1, I could split the product. If it was x divided by 1, I could split the quotient. If it was x to a power, I could do something. But this is actually already simplified, There's no product, there's no quotient, there's no exponent. So there's nothing I can do to expand this one. That's already fully simplified. So that is the answer, okay? Now, for a little comparison, if we saw something like this, log base 5 of x plus 1 squared like that, well, that could be expanded because the 2 up here could be pulled out in front, and I could make this 2 log base 5 of x plus 1, okay? So that's how something like number 8 could be modified so that it can be expanded. One more comparison, if this was log base 5 of x squared plus 1, so now if the squared's inside, you might be tempted to pull that 2 out in front like I did on the previous one, but I can't actually pull anything out here because that 2, while there's an exponent inside, it does not apply to the entire inside. So this also is already simplified. There's nothing you can do to simplify this one. So just because it tells you to expand an expression doesn't mean it actually does. Most of the time it will, but occasionally it will not. And that is expanding using the properties of logarithms.